Hey Algebra 2, today we are going to show you how to multiply and divide radicals. So here we go. So here is a property of radicals. It says for any number a and b that they could be multiplied together under the same radical, or you can separate them. What is important here, so you noticed all those are n's, they have to have the same index. Must have same index. So if you look at example 1 here, I have the square root of 5 times the square root of 7. There's no index there, so it's an implied 2. So that property says that you could multiply and put them together under the same radical, and 7 times 5 is 35. So sometimes it's more beneficial to multiply them, and sometimes it's more beneficial to separate them. Depends on the number. When you have the next one here, so I have the cube root and the cube root. So I have the same index. That's great. So therefore, I can just go ahead and multiply -4 times 2 and get the cube root of 8. Well, we've been doing these for a few days. Hopefully you know the cube root of 8 is -2. On the next one, I have the 4th root of 6 times the square root of 2. I cannot do that because I have a 4 there and I have a 2 here. This, I would say, is fully simplified because I have different index. Number 4 is different. Number 4 says, if you go back here, it says that a and b have to be a real number. So this is the cube root. I'm allowed to take the cube root of a negative number because a negative times negative times negative gets me a negative. However, right here, this says I have to be able to take the square root of this -4 first before I'm allowed to multiply it by this radical -1. Well, the square root of -4, we learned a long time ago, is 2i. That's an imaginary number. And then the square root of -1 is I, also an imaginary number. For our purposes in General Algebra 2, we're going to say we can't simplify this. We certainly can, because if I can multiply these, but we are not going to handle that this year. So what you need to know, the difference between number 2 and number 4. If your index is an odd number, it is okay to take the root of a negative number. It is okay to have a negative there. But on number 4, if your index is an even number, you will not take the root of a negative number. All right, here we go, number 5. If you look up here at the steps to simplifying, step number 1 says multiply the numbers and the variables under the radical. So there's a property of multiplication that says I can multiply these two numbers and I can move them around any way that I want to. So I'm going to move the numbers and group them together, and I'm going to keep the variables together. I think that's going to help me. So I did this because I cannot take the square root of 5. I would get a decimal of some sort. And I cannot take the square root of 20. I would get a decimal of some sort. But if you multiply them together, 5 times 20 is 100. So it was better to multiply them because the square root of 100 is 10. I left my x's like this for a couple of reasons. Mainly because this exponent and that index are the same thing, and I knew that they would offset each other. So the square root of x squared is x, and then I have this lone x right here, and I can't do anything with it, so it stays under the radical sign. All right, so if you don't like this way, what we had done before last week, I'm just going to focus on my variables here. So this right here is the square root of x to the third. So if you said, oh, I'm supposed to multiply these together, okay, sure, let's go ahead and do that. A lot of you had success by writing them all out. So x to the third means that there's 3 x's under the radical. I have an implied index of 2 right here. Your index tells you how many go together in a group. So I can make one group, so that means one comes out, and then that other one stays in. I get the same thing. The other way that I showed you, if we go back to looking at this x to the third, I told you to take your exponent divided by your index. So 2 goes into 3 one time, with 1 left over. That tells me 1 comes out, and 1 will stay in. Number 6. All right, I'm going to multiply these 2 radicals together. That 2 and that 5 that are outside, I'm going to multiply them together in a minute. So numbers outside of the radical, they stay outside, and I can multiply them. I'm going to rewrite that as 3 times 15. And x to the third times x. So 2 times 5 is 10. 3 times 15 is 45. X to the third times x to the first is x to the fourth. One moment. All right, so now we need to work on simplifying 45x to the fourth. All right, so my index is 2. So when I break this down, I'm thinking, what are my perfect squares? 4, 9, 16, 25, 36, etc., etc. So 9 is a factor of 45, and so I'm going to break that down into 9 times 5, x to the fourth. The square root of 9 is 3. And so when you take the square root, it comes out from under the radical. If there's already another number outside of the radical, you should multiply these in a minute. And then the square root of x to the fourth is x to the second. And I can't do anything with that radical 5 other than write it down. I'm going to multiply these 2 numbers to finish it off. And this is 30x squared, radical 5 is my good final answer on that one. Number 7 and 8, now I switch over and I have cubes. So they each have the cube root right there. And so when I see cubes, my perfect cubes are 8, 27, and 64. I'm going to keep those numbers in my mind. So the first thing I'm going to do is I'm going to multiply these 2 numbers. So I'm going to have 4 times 2 and x to the fifth times x to the fourth. 4 times 2 is 8. When I multiply variables, you add your exponents together. Well, this one turned out pretty nice. 8 is a perfect cube. The cube root of 8 is 2. And then the cube root of x to the ninth is x to the third. Because remember, when you do variables, you take your exponent divided by your index. And so that just gives me 2x to the third. Number 8 became a little bit tricky. First thing I'm going to do is I'm going to rewrite it and put my numbers together and my variables together. 4 times 32 is 128, and that becomes x to the 10th. So in my calculator, I just started taking 128 divided by 8, and that worked out. This is the long way of doing it. 64 is also a factor, but I find that most kids don't realize that, so I am going to do it kind of a long way. So 128 is 8 times 16. 8 is a perfect cube, and the cube root of 8 is 2, so that comes out from under the radical. I don't know why I started writing an 8 there. I'm so sorry. How about I write negative 2? I was probably looking at the answer. That's a 2. Okay. 16x to the 10th. All right, so I have negative 2 times 2, which is negative 4. Cube root of 16x to the 10th. You're not done simplifying until the number under the radical doesn't have any factors that are perfect cubes. Well, as it turns out, 8 times 2 is 16. So there is one more factor that I can pull out here. So I'm going to rewrite that as 8 times 2, x to the 10th. The cube root of 8 is 2. And then it's probably about time for us to deal with x to the 10th right there. So I have 10 divided by 3. That goes in there 3 times with 1 left over. So that tells me 3 x's can come out and one of them stays in. X to the 3rd, the cube root of 2x. And then I would finally go multiply those numbers and get negative 8, x to the 3rd, the cube root of 2x for my good final answer on that one. That is more of the same. That is more of the same. Number 11, I'm going to move on to quotients, and we are going to divide them now. So when you are dividing them, 8 and 2 are not perfect squares, and so if they are separate, like they are here in the second part, you can put them together and have them all under the same radical. So this is the same thing as the square root of 18x to the 5th over 2x to the 3rd. So when I put them under the same radical, I see that 18 divided by 2 is 9. And when you divide variables, you subtract their exponents. So I don't have any terms in the denominator now. I have 9, x to the, hey, that's a 3 and that's a 2. This is mistake central today. There we go. The square root of 9 is 3, and the square root of x squared is x. So once you put them together under the radical, numbers divide as they normally divide, and then variables you just simply subtract. So I don't think 162 and 3 are perfect cubes. However, if I rewrite them and put them under the same radical, I did 162 divided by 3, and I got 54. I'll clean that up in a minute. And when you divide variables, you subtract their exponents. So I have the cube root of 54 y to the 3rd. All right, so I have a cube root here. So 8, 27, 64. Those are my first couple perfect cubes that I keep in mind. So I went 54 divided by 8. Nope. 54 divided by 27. Yes, that one worked. So that breaks down into 2 times 27, y to the third. 27 is a perfect cube, that is 3. The cube root of y cubed is y, those exponents and that index cancel each other out. And then I still have a 2 under the radical, and voila, there you go. And I think that's where I'm going to stop for now.